Hey everybody. Today we're talking about percentiles. Percentiles measure the relative position of observations in a set. More specifically, the pth percentile of a set is the value that's greater than or equal to p% of the data. To find the percentile of a particular observation in a set, you calculate the fraction of values that lie below it. So to find the percentile of x, you take the number of values less than or equal to x, divide by the total number of values. We then typically multiply by 100 and round to the nearest integer so that percentiles are numbers between 0 and 100. Let's do an example. Here's a small data set, and I'd like to find the percentiles of the two values 72 and 16. So this is a good place to pause the video and try and do this on your own. So looking at 72, 12 of the 15 values are less than or equal to that. So 72 corresponds to the 80th percentile. I've done 12 fifteenths, 12 out of the 15 values are less than or equal, and then multiplied by 100 to get 80. The value 16 has 4 values that are less than or equal to it. So 4 divided by 15 times 100, 26.66667. So we round that up. This is the 27th percentile. One thing that you have to be careful with is that the definition of percentiles varies very slightly from one source to the next and is computed very slightly differently from one piece of software to the next. Some sources use greater than instead of greater than or equal to, and there's not really any logical reason to prefer one over the other. Greater than or equal to is slightly more common, but again, you have to be careful because there will be some differences from one source to the next. The good news, though, is that the resulting differences in the values that you get out of calculations using these different definitions tend to be really minor. As with just about everything in statistics, percentiles are almost never calculated by hand. We use technology. In R, we can find the percentile of a value in the set using the ECDF function. So to do that, we have to pass ECDF, the vector that we're actually using. That actually gives you back a function that will then compute the percentile of whatever value you pass it. So then we close up the parenthesis, open a new parenthesis, and pass it the actual value. So for instance, with this data right here, the value 16 is about 27th percentile. Do notice that ECDF does not round the values automatically. That's something that we get to do on our own. Conversely, we can estimate the value in a set that corresponds to a particular percentile using the quantile function. So while ECDF was taking a value in the set and giving back its percentile, now we're taking the desired percentile and getting back a value in the set. For instance, quantile x, 0.10 gives back 11.8. This lies above about 10% of the data in this set. Two things to notice about that. First of all, quantile wants the percentile as a decimal, so we've passed it 0.10 rather than 10. Secondly, you notice that 11.8 doesn't actually lie in this data set. And that's a normal thing when we're doing percentiles because there isn't one value in this set that lies above exactly 10% of the data. And so R is doing a little bit of interpolation. And there's different choices for how you do that interpolation. R does it in a very standard way. My advice is to not get under the hood with that too much unless you absolutely have to.